the energy of Bohr orbit? Do you have any idea about the energy of Bohr's orbit, Sanoy?
Sir, I know that every orbit has got a certain energy level, that is n equal to 1, n equal to 2, and n equal to 3.
Oh, okay, that is great. But how you will calculate the energy level of these orbits? Suppose this is the Bohr's orbit, which I have mentioned. Okay, this orbit is what is the K orbit, L orbit, M orbit, N orbit, and O orbit. Okay. Now, what we need to do, we need to find out the value of the energy of this orbit. Will this orbit energy is increasing on moving, no, away from the
Yes,
nucleus or getting decreased away from the nucleus? What is happening?
sir, away from the nucleus, the energy level is increasing, and near the nucleus, the energy level is decreasing.
Okay, means you are saying if these orbits are there, so means this orbit of energy increasing, like that you are saying.
Yes, sir.
Increasing energy. Okay. But by what factor it is increasing, that we have to understand. By what factor it is going to increase? Any idea? So, Sanoy, there is no problem. Okay. So here, if I will go the energy of Bohr orbit, and we are writing this is En. N means the orbit number, right? N is the orbit number. Here I am mentioning orbit number. And this is the orbit number. If you are going, this is K, this is L, this is M, this is N, O. Any imaginary number, it can be also infinite also. So the value of that is, this will be the 1, 2, 3, 4, 5, any number it will be. And how we calculate? No, minus 13.6. This is there into, this is the Z upon N square. Z upon N square electron volt. This is what the formula. Okay. Here, if you talk about Z, Z is going to be atomic number. Atomic number. And if you talk about the N, this will be going to be the orbit number. Orbit number. So if I'm going for H atom, if I will go for the H atom and H atom first orbit, if I will consider first orbit, and then we put the E1, it can be E1. So it will be minus 13.6 into 1. The atomic number of hydrogen is 1. Here is 1 squared. So it is going to be the same one, 13.6 electron volt. And this will be in the negative. Is it okay?
Yes, sir.
Okay. Now, if I will ask, that is, tell me the second orbit. What can be the answer for second orbit? If I will go for the second orbit, can you tell me what is the energy of second orbit? And is it increased energy or the decreased energy? Sanoy, here the Z square is there. Excuse me. This is also Z square, not the only Z. This is the Z square. But if you are putting 1 square, that will be same. Please you put the Z square.
Yes.
Minus 3.4 volts. Thank you very much. Minus, it become minus 3.4 volt. So this is increased or decreased? Minus 13.6 and minus 3.6. Yes,
Sir,
sir.
minus 3.4 is greater, so it is increased.
It is increased. So that it will go away, it is going to increase, right? It is going to keep. Okay, I am giving you on the question here. Question is what? Find the energy of, here question is find the energy of Bohr's orbit. Bohr's orbit of lithium atom. This is what they are saying. Lithium atom. We are having lithium atom for its third orbit. This they are asking.
Sir, but the formula you gave, sir, that is minus 13.6 into z square by l square ev. Sir, this one is for one electron species only, na? Like hydrogen-like species.
Lithium
Sir,
ion,
then
lithium ion. You put the
yes,
lithium ion,
that's what I'm
lithium
saying.
ion.
Third
Lithium ion
orbit, sir,
means
that
Li
will
3
be
plus.
one second.
And question got increased and its ratio they are saying, and its ratio with third orbit of hydrogen. That is correct. No problem. Okay, correct. Thank you. So this is what something the energy of Bohr orbit and what we have done. The another things also we have done. Hello. अरे सर आप मैडम के पास कॉल करिए ना, मैं ऑनलाइन क्लास ले रहा हूँ. अच्छा कौन सा नंबर है लास्ट में 700 से चालू है, 931 है सर. Okay, so this is what the energy of the Bohr's orbit. So no, a little bit order from the NCERT I am changing. I am telling you the different things. Then again I will come back from the spectrum. Okay. So firstly, I want to teach you the quantum number and configuration. Okay. So a little bit order I have changed. Okay, for teaching order. Yes. Got it? So here if you see after the orbit, what we have done, that is orbit we have studied up to here. Okay. Now orbit is subdivided into orbital. This is subdivided into orbital. This is also called subcell. Okay. And orbit is called, that is what we said, that is cell. Is it okay? Yes or no?
Yes. Yes.
So cell is divided into subcell. Okay. Orbitals are, how many types of orbitals are there if you talk about orbital? SPDF. It can be the SPDF. That is okay. There are many, but he is calling, I don't know what. So here, hello, Malvika. Yes, sir. Sir. Malvika, sir, I'll call you, sir. थोड़ा सा मैं क्लास ले रहा हूँ, sir. Okay, right. Okay. तो इधर में हम बात कर रहे हैं, देखिएगा थोड़ा सा. ऑर्बिटल तो आप बता दिए, कौन सा बता दिया आपने, बताया एस ऑर्बिटल, पी ऑर्बिटल, फिर डी ऑर्बिटल और फिर क्या लिख रहे हैं, एफ ऑर्बिटल. तो ये 4 टाइप के तो ऑर्बिटल हो गए, है ना. बट हाँ, बट simultaneously you tell me the shape also. This is the spherical shape.
So this should be dumbbell, this is double dumbbell.
Okay, this is the dumbbell, double dumbbell. Okay, what are the types here? What are the types here?
The type means I did not understand, sir. What
they are also, these orbitals are also types. What is the shape of the F orbital?
The shape I do not use, sir, for
this is the diffused shape. Okay. Now if I will ask you, Sanoy, this is the how many types of S orbital possible? This is only one type. Okay, only one type. So s orbital is one type. How many type of p orbital? Do you know? 3 type. Yes or no?
No, sir.
Okay. This orbital, if I will go d orbital, this is the 5 types. You must be knowing this one. 5 types. And this orbital are how many types? 7 types. Okay. First of all, I want to know that is how many maximum electron is possible in s orbital.
2.
2. Okay. So here is s orbital is only one type. There is the rule. Okay. The rule say one type of orbital can have maximum 2 electron. Okay. So if I will
Sir,
ask you,
if this is one type, sir, then for this one type would be like this. So
uh,
this is having two ones. So sir, one should be the full field,
uh,
another should be the half field,
uh,
and another should be like
hmm,
only one is filled. Like
hmm, hmm. No, not like that. We cannot say here. See, p orbital is total 3 types. Got it? P orbital is total 3 types. So maximum electron can be of how many? 6 electron. One or type of orbital can have maximum 2 electron. It is having 3 types. So it will having the how many?
6
Total electron will be 6 electron. So we can write 1, 2 electron orbital field according to Hund's multiplicity rule. And firstly, they will fill 1, 1, 1. Once it is singly filled, then they will get paired. So here is
Yes,
6
and
electrons.
first the plus half spin will fill, and then the minus half spin will.
Yes, thank you. So no, here the d orbital are there. D orbital, you told how many maximum electron?
D orbital is 10.
10 electron. So we are mentioning. So you already, you know very well, that is the firstly the half spin plus half spin are getting filled, 5 electron, and then it is going to be the remaining half spin, and that is total it become 10 electron. Okay. Now, if you are talking about this one, F orbital, it is going to be total of the 7 type. 1, 2, 3, 4, 5, 6, 7. And if you are filling the electron, so electron is going to fill one by one only. So here is 1, this is 1 and 1. And you will find that is total how many electron going to be in F orbital?
14.
This is the 14. So this is the actually very basic idea. Now, can you tell me what are the type of this p orbital? This is the px. It can be py and it can be pz. Okay, this is what tell me the d orbital type.
Sir, pxy.
No,
Sir,
dxy. Dxy.
pxy,
Uh,
dyz,
hmm,
dzx,
hmm. Dx square minus y
dx
square,
square,
dz
dy
square.
square, d square.
What are the difference in these orbitals? What is the difference?
No,
What
sir,
is
I
the
don't
difference?
know this. Sir. I
Okay,
don't
okay.
know this.
Hmm. So you firstly, whatever you are knowing, the diagram. Asa, close the gate, please. Diagram, diagram of orbital. Okay, diagram of orbitals. So you better you draw and you try to draw. Okay, so already you because you told the safe. So s orbital you draw, then you draw p orbital, then you draw the d orbital. F orbital, can you have you seen the F shape of F orbital?
No, sir, f orbital.
Hmm. Okay, so no, very good. So representation s orbital can have 2 electrons. So for 1 electron, we represent 1s1. And for 2 electron, we represent what? 1s2. Okay. Now, p orbital, you wrote only one type of p orbital, but that diagram is not correct. Okay. That is what you are writing. See, in case of p orbital, the lobes are along the axis. Okay, lobes are along the axis. So this become the px orbital. If you are writing the py orbital, you need to put the lobes of the p orbital where you need to put on the axis. And pz orbital, if you are making, that is also you need to put it like that. Okay, z. So x, y, z. The lobes are along the axis or on the axis. Here, what you done? This is okay. This is the x and y. If I am mentioning x and y, so this orbital is called, that is dxy. If you are mentioning the same one, suppose you mention y and z. So here if you are mentioning the lobes like that, okay. So this orbital is considered to be dyz. And next one, if I will consider dz, okay, here, this one. So you can consider xz, so dxz. There is no problem is. But here another set of orbital are there. Another 2 more orbital are there, you wrote. That is dx square minus y square. So lobes are there on the axis. Okay, that is also called along the axis. So here you can find that is on the axis. Kindly see this one. So here is dxy. So it will be the named as dx squared minus dy square. And remaining one more orbital is there, Sanoy. The firstly it is looking like the 0, but it is not the 0. It is something like the spherical, okay, circular.
Yes, sir. It is seen from the third person perspective, like from above.
Thank you so much. So here you see this one. So this become the z. So that is dz square. This set, if you go, this 2 set, it is called EG set. EG. I know, EG set. EG set. What do you mean by EG set? Double degenerate. Okay, double degenerate. What is the degenerate orbital? Sanoy? What is double degenerate orbital?
No, sir, I don't know.
Degenerate means having the same energy. So d orbital of 5 types, right?
Degenerate is same energy, but I don't know what is double degenerate.
Double degenerate means 2 orbital. These 2 orbital is having the same energy, right? This dx square minus y square, dz square. They are having the similar energy. Got it? So it is called double degenerate. Here this set, what is you wrote this one? This is also called T2G orbital. T2G means triply degenerate or triply, triply degenerate. Okay. So these 3 orbital is having same energy, this one. And it is diffuse shaped. F orbital is very much diffuse shape, which cannot be drawn on the paper. Okay, for F. Can I erase? Can
Yes,
I
sir.
erase?
Yes, sir.
So no, it's say you will study in the coordination compound this one very easily, but little bit I'm giving. Suppose it is the d orbital. When d orbital is getting split now, so it formed the 2 types of. It is split into the 2 way. What are there? It is the T2G orbital and EG orbital. No. Oh, sorry. T2G will be downside. T2G. Its name is triply degenerate. These 3 orbital is having same energy, and this is called EG orbital. These 2 orbital is having same energy. So that is why I told you. Okay, later on it will be very much helpful to you. This one is dx square minus y square and dz square. This is, and here is what is there, dxy, dyz, dz. Done.
1 second. Sir, yes, sir. Done.
Split this is what is splitting of d orbital. Splitting of d orbital. D orbital. in presence of ligand. Ligands. Ligands. Ligands means lone pair electron containing species. When the lone pair electron containing species approaches the d orbital, so what will happen? There occur repulsion, and this d orbital is split into two ways. First one dx square minus y square dz square, and here is dxy dyz dzx. So this is the two things are there. Can I erase?
Yes, sir.
Now, so these things. One more rule we have to study. What is the rule? Firstly, I told you Hunt's rule. Can you tell me Hunt's rule?
Sir, Hund's rule, sir, the physical implication of Hund's rule is that the electrons, while filling up of the electrons, the electron of one spin will fill up first, then plus half spin will fill up first, then the minus half spin will fill up.
Okay. Means the filling of electron takes place in the orbital one by one. Okay. Yes, na?
Yes.
Suppose suppose it is the d orbital. So what you are going to do? What you patiently wait.
That
We are.
first it will be like this.
Uh-huh.
Sir, first the plus half spin will come, then the minus half spin will be coming.
Okay, then you are knowing very well. There is no need of this one. Okay, next one. If you are talking about above rule. Okay, above rule.
Yes.
That AUF BAU above rule. So you must be knowing this one. Tell me please this one also is statement.
Sir, above rule is the rule of the filling of the various shells in the various subcells according to the electrons. Like this can be expressed in this form. So that 1s2, 2s2, 2p6, 3s2, 3p6, 3d10.
Okay, good. What will be order of this? What will be the order of this?
Like then we will form this one, sir. Then according to this we will be having the order.
So it means third orbit. If I will consider you third orbit, this is the first orbit I am writing, and here orbital I am writing. So if I will ask you the orbit number 1, 2, and 3. This is the 4th, 5th, 6th, and 7th. So if I will consider you third orbit, so which orbital will come in the third orbit? And how many electron will be?
Orbit, sir, sp and d will come. Third orbit sp and d will come.
So total electron will be how many?
Sir, total electron in third orbit will be, sir, 2 plus 6 plus 10. Sir, 18.
18. So you are correctly doing this one. Okay. So do not need to write this one above rule.
No.
Okay. Okay. Let us have a look over the configuration. Some of the configuration also you tell me. Configuration. Okay. What do you mean by configuration?
Sir, the sequence in which electrons are arranged inside.
Okay. So you write down the chromium. You write down the Mn. Then you write down the copper and then zinc.
Sir, zinc and copper. Manganese. Sir, manganese. Sir, chromium and manganese are atomic number. 1 is 2, 2 is 2, 2 is 6, 3 is 2, 2 is 6, 2 to 4, 4, 6, 10, 10, 12, 18.
Wrong. This become wrong.
Sir, which one?
Copper one. Copper one, what the rule you are going to follow? This rule you are going to follow, no? Stability rule. That is what you
Yes,
have.
copper also some other configuration was there as
Like this. So what will be there?
But firstly, this 4s2 will be there. So then
No, dear.
3d5.
No. 4s1. 4s1. And here is 3d10. Now count 2 to 4 to 6, 10, 12, 6, 18. 18, 10, how much? 28 and then 1, 29. So this is the what rule, according to what rule we are filling? We are not filling according to
The
above.
half filled and full filled shells are more stability.
That is stability of half filled and full filled orbital. Very good. Okay. So already you know. One more questions. I want to give you the questions because you know mostly things you know. The question is out of the orbital, given orbital, out of the given orbital, what will be given orbital? In which electron filled first? In which electron will filled first? Will filled first? Will filled first? This is what the questions. Write order. We have to write the order also. ORD. So what are there? It is the 4s is there. 4s. Then here is 4p is there. No. Okay, let it be 4p. Then here is we are having the 3d. We are having 3d. This is the 3d. And next one is the 3p as well also there. Okay, these many are there. Okay. We have to see that is in which the electron will fill first. And what the rule you are going to apply. Name rule also we required. Which rule you will going
this
to
only
follow?
will be filled first. This is the above rule.
No, not the above rule. N plus L rule. One more is there. N plus L rule. Have you heard about this one? N plus L rule.
Yes.
What is this rule?
Sir, n plus L rule, sir, means that we will, for example, for 4s, sir, we are having the quantum numbers as n equal to 4, L equal to s minus 0, S means 0, and m equal to also 0.
Okay,
and then we are s equal to plus
so,
half or minus. This is not much significant over here.
Okay.
Sir, but if we go to 4p, sir, 4p, sir, here also we are having n equal to 4, L equal to SP, no 1. M equal to minus 1, 0, plus 1, and S equal to plus minus 1. Sir, by this way, sir, we will find out that which has the n plus L values, sir, like this one has 4, the next one is 5. Sir, like this, and then we have to see that which have n plus L value the lowest. And if two are having this equal n plus L value, sir, then we have to see that which has the lesser n value. So that will be filled first.
So you are saying that is its value is coming 4 and its value is coming 5. Its value is coming, again it is coming the 5 and it is coming the 4. So these two are the same, right? So order you are saying that is 3p, then it will come 4s. Is it okay?
Yes.
Then these two are also 5 are there, so it will come 3d and then 4p. Is it correct?
Yes, sir.
Okay. Now let us see, do the question, because most things you know. Here is the what is the find all the 4 quantum number. I am writing different way. Find all 4 quantum number. All 4 quantum number for last 2 electron of CS. Last 2 electron of Cl. Cl, not Cl minus, chlorine. Atom. Here is already written chlorine atom. Okay. Do it.
Six to 6 4 12.
Very good.
No. Sir, done.
So 2 electron, you are calculating for 1 electron. For each electron, M, how many value you are writing? One value you need to write now. You are writing all the values. They did not ask. Find all 4 quantum numbers for the last electron of Cl atom.
Sir, this should be -1 or 0 or 1.
No. For each specific, it can be either it can be on the x-axis or the lobes will be at the either x-axis or minus or y-axis or z-axis. There is 3 possibilities now. So where the electrons are there?
Sir, that how can we say that where they are there?
That is what. Okay. So 2 things you wrote. Okay. See, first of all, these things you have to make qualified this one, which is the last 2
This one
electron.
would be plus half or minus half. This is would be totally correct.
No, how can you say? Only one option you have to give. Where you
So
will
that is
find
why I
this?
wrote or na, whatever anyone can it be.
But the electron, if the electron is mentioned there, then which one will be there? Which one? Which one you are mentioning the clockwise? Suppose you are mentioning the first electron. Are you going to mention downside or you are going to mention upside? Where you are
Upside.
going? Upside. So here there is the rule is there. Okay. Now let us see the total 5 electron. Up to here, how many are there? 12 electron. There is no the last electron in these 12. So it will be this is the 13. This is the 14. This is the 15. Here is the 16. And this is 17. So this electron, if you are considering, this is I think 16th electron. If you don't mind, can you tell me? And this is the 17th electron. Yes or no? Yes or no? No. Are you listening?
Sorry, sir,
Hello.
my mic was muted accidentally. Sir, yes, sir, they are the 16th and 17th one.
That is correct.
Sir,
Na?
both will be having minus half value only.
That is minus half. But you wrote here plus now.
This is one.
Okay. Something you missed that I want to tell you. This is we are going for the 16th electron. This is and we are going for the 17th electron. One thing you are correctly saying that is n value. So n value here you are saying that is 3, absolutely correct. 3. L value also you said p orbital is there. So 1. This is absolutely correct. M value. See the rule for m value you wrote. What the rule you are writing the m value? M is equal to you are writing minus L2 0 to plus L. Like that you are saying.
Yes.
So here is L value is 1. So it is -1, 0 and +1. This is there. This is the M value. Now what we are going to do, we are checking out. This is the orbital. Here is the px, this is the py, and this is the pz. Or the last electron is this one. This is the last electron. These 2 electron are last electron. So when you are making this one, what is the value of M for this electron? Can you tell me? Value of M is -1. And what about for this electron? What is the value of the M? So M is equal to it is the 0. Are you be able to understand?
Yes.
Then if you are talking about the S, this is minus 1 by 2 and also it is minus 1 by 2. Can't
Yes,
you
sir.
understand?
Sir,
Done.
understood.
Okay, very good. Now, I'm sharing you again the link. Now you joined once again because
Yes,
it
sir,
is
yes.
okay. 1 second. Let me end the meeting.